So today we're going to be diving into the world of appropriate performance, which just so happens to be our design fundamental number 4. So what is appropriate performance and why do we want it? So first of all, appropriate performance typically in the market is labeled as high performance. And people within our industry are looking to change this to the terminology to appropriate performance for a very specific reason. And that is to do with the fact that the idea of something being high is aspirational. It's hard to achieve. It's expensive. It is something that's only for the wealthy and those who really care about those things. But we want to try and change that perception. We want to make sure that people understand that building performance at the right level is appropriate and it needs to be across the board and for everybody. First of all, to understand why we do this, we need to understand the current landscape of what the current standards are out there and what sets us apart from that, how we're achieving appropriate performance. So the minimum standards at the moment in Australia are 7-star NATHERS ratings. So let's break that down a little bit. What is that and how good is it? Well, it's an improvement over what the 6-star was that we had previously, and a great improvement at that. However, if you looked at my last video, you'll see there are some issues in that need to be resolved, and it needs to be designed in a specific way to control some of the problems that come out of that. But in reality, a 7-star building is actually legally the worst building you can build in Australia right now. Doesn't sound like a good performance, does it? It sounds like, that is the base bottom standard. It's literally you can't do worse than that and achieve a building. So we need to try and aim higher than that. So why do we need to do that? Well, buildings are supposed to last for a long time, right? They're not short-term commodities. They're not something that we design now and we change in the future. And that's not the way we should be thinking about it. We should be thinking about creating something that is the best building we should create right now so that it will last for a long period into the future. So minimum standards, 7-star NATHERS, not great. It's not suitable for the long term. It's going to, as in a year or two time, the Australian government have got targets for net zero, right? And to do that, they're going to have to raise the bar on energy use within buildings. And that means that we're going to get 8 stars, we're going to get 9 stars, we're going to get 10 stars in the future. And that's the only way they can actually achieve this, their pledges towards net zero. So knowing that, and knowing that buildings last for a very long time, why would we do a 7-star building now? It doesn't make any sense. We need to try and aim for better than that. The next one is 7-star, the process to achieve a 7-star building. I need you to understand this. This is a fundamental problem within the industry. The current standards is a paper-based assessment. When we as architects or any building designer designs a building, we have an energy rater who will assess that design to ensure that it is achieving the 7-star requirements, which is great. We've got an independent person doing that. There's a system, and it's a checkbox system that goes through and ensures the building is actually achieving that standard. However, that's where it ends. When that building then gets a building permit and goes onto site, there are no checks done to ensure that that energy rating and all the work that's been done in the design to that point is actually being achieved in reality. So, and it's not always builders' problem, although builders can be a part of the problem on this. But I'll give you an example, right? So let's say that you have a wall that was R3 required insulation in that wall to achieve a 7-star rating. Let's just say that the builder knows that and they've done their best to achieve it. They've built the wall exactly as per the drawings. But then a plumber comes along and they need to put in their pipe into that. The electrician comes, they need to put their electricity wires into that, and their conduits. The mechanical service engineer comes along and they need to put in their mechanical ducts. All of these things have not been taken into account in the modeling, in the paper assessment that happened. And typically what's happening is the trades that put these services in, they need to take insulation out to put their services in. And that is a reduction in that wall performance. And often after these trades, they don't put insulation back the way that they should. And the wall gets plasterboarded up. Nobody checks it. Nobody has a thermal camera to ensure that the performance of that wall is achieving the standards that it said it should. Now, the problem with that is not only the lack of energy efficiency in that wall that's been decimated by the services put into it, but you paid for a 7-star building, right? As a client, you have a certificate there that says that you have a 7-star building, but there is no way of proving that in reality. And you can be sure, and in my experience, this is guaranteed, that every time you see an as-built product versus the certified product, they are not matched. And you have paid for the certified product and you're not achieving that in reality. And that's not good. We want to ensure that you, as a consumer of buildings and somebody who's going to live in these buildings for a very long time, is getting proper value for money out of that process. What's more is it's very difficult for you then to market that building in the future as being of a good performance. And what's going to happen is, as the standards raise to 8-star, 9-star, and passive house, potentially other standards coming in the future, your 7-star building is going to be quite low down on the pecking order. So people looking for more and more energy efficiency in the future, as the general public become more aware of the importance of this, that don't want to have to retrofit their building to achieve the standards again in the future, will be looking for a product that is beyond, or at least at that market level at that point in time. And so it's going to be very difficult for you to again see that value in the future with that building product. So appropriate performance, let's put this into context for you and give you an idea how this works. So with appropriate performance, we set out with a different mindset. We set out with the mindset of creating the best possible building possible at that moment in time, not the worst building standard. We achieve the best we possibly can afford. We put energy and we put a lot of thought and process into achieving the best possible standards from the outset. So that means that we've built in longevity into that build structure. We've made sure that it's going to be energy efficient into the future. So if the code changes to 8, 9, 10-star in the future, we're already there well ahead of time. So it also means that you then can market that and you can actually get better value if you want to sell the home in the future, because people will realize they don't need to retrofit it. They're already at a good standard and they're going to be comfortable in that home. What's more, and this is probably the most important part, is the appropriate performance solution that we offer has a certified as-built solution built into it. That means that we do blower door testing on site to ensure the air tightness of the building and the structure is actually being constructed in the best possible way to a very tight regulatory detail. We do thermal camera checks on the walls to ensure that the insulation is in all of the right places. We design the walls appropriately so that the services don't conflict with the insulation layer. The insulation layer remains consistent throughout all of the building fabric, including around all the junctions and where services would usually be. So that has been designed and it's been checked and it's been certified by an independent certifier on site to ensure that that has actually achieved the standard. It means that you have actually got value for money. It means that you've gotten what you paid for up front, and that is the product that you're going to be living with. So much better, right? It's a completely different building type altogether. And obviously doing this takes more care, it takes more diligence. It does cost a little bit more, but you're going to see much better reward. You're going to see a lot more reward out of doing this than you are out of designing a custom piece of joinery, which may cost the same amount of money as the upgrade that you need to do this type of work. So think about it in that long-term relationship with your building and how you interact with it and how important this is going to be in the future. So I mentioned how we do it to a certain degree there, and we do it using Passive House. So Passive House is a German standard designed in the 90s, which has been tested again, buildings that were built in the 90s, to ensure that they are still achieving the same standard that they were built with back then, that is certified back in the 90s. They've been tested recently and they are still at exactly the same level they were. So there's no degradation of the energy use in that building. It's still consistent over time, and that obviously is something that not only you as an occupant will love and the comfort aspect of it, but again, you can sell that to somebody and demonstrate that to them, that they're getting that value. And so with Passive House, there are 5 fundamental ideas that need to be adhered to in the design and the construction. Number 1 is consistent insulation. Like I mentioned, we need to ensure that it's consistent around the whole building envelope, that services are not compromising that in any way. So there's a lot of thought and detail goes into that. Second one is that we need to have high quality windows and doors within the building fabric itself. Windows and doors are a much thinner profile than the adjacent walls that they're typically in, and therefore they typically perform from an energy point of view a lot less than the walls that they are within. So we need to ensure that we maximize the capacity of those elements to perform. And so that means that we need at the very least high quality double glazed windows with thermal breaks in them, possibly even triple glazed and good quality window frames that don't allow that energy to leak from one side of the building to the other. Next one is airtightness, ensuring that their internal environment is actually maintained and kept in there through airtightness, so that there are no gaps in that structure for the energy to leave the building. And this is tested on site, as I mentioned, through blower door tests. And typically a building with appropriate performance will be around 25 times more airtight than a traditional built 7-star home that hasn't had airtightness considerations. The next one is what's called thermal bridges and removal of thermal bridges. So an example of this is where you've got a steel beam that's supporting your floor internally, that maybe then goes outside as well and supports a balcony externally on the building. So that is a metal element, is a thermal conductor that connects the inside structure to the outside structure. And being a thermal conductor, it's actually drawing energy through the member length itself. So we want to try and avoid that, so that we have structure inside the house and structure outside the house, and those two are separated in some way thermally, so that there is no bridge between the two elements, and therefore energy passing from inside to outside doesn't happen. And the last one is mechanical ventilation, mechanical heat recovery ventilation, should I say. And this is an important part. So if we've got an airtight building, highly insulated, we need to ensure that the indoor air quality and the right amount of oxygen is maintained inside the building at all times. That doesn't mean that if this unit is shut off for a period of time that you're going to suffocate or anything like that. It's completely healthy to have it off for a short period of time. But the idea is that it runs in the background 100% of the time, and it's constantly replenishing the air internally, and it's also recovering the energy in that air and recycling it into the building, but removing the toxins from the air at the same time. So again, if you want to know more about that, check out the last video on design fundamental number 3, health and well-being, where I touched on that a little bit more. So that's what appropriate performance is. And it sounds good, right? It's something that we all should need. It's something that we should be aspiring to have in our buildings. And it is achievable. It's not difficult. It can be done in any building. It can be done just through proper care and detailing that will allow this to give you a much healthier, energy efficient building into the future. I hope you find that useful. I'm Roger Borland from Borland Architecture. If you'd like more information, just leave us a comment below or get in contact directly, and we'd love to help you out. If you find this of use, please like, subscribe, share it with somebody else who you think might really benefit from it too. Thank you for watching.